So it's a town hall debate. So anyone that was holding back their questions from earlier that would like to ask the panel, they are available now for questions. I might drop some in as well if I need to spice things up. But let's see where it goes. So anyone in the audience got who's giving the first one? First question. Okay. Okay. Yep. Who wants to pick that one up?
Why is an industry always having to label things?
I think, I think it goes back to, well, it's a couple of things. So the origin of modern data stack started with the companies like Fivetran, DBT, trying to establish a name onto an archetype, right? But if you dug under the hood for 5 seconds, you realize it was not different than what we had before. I mean, I think you all had some slides on this whole thing. So, but it was a movement, right? And every movement needs a name and so forth. But I don't think there wasn't really like a modern data stack. You know, we didn't call it that before. But I think it was an unfortunate name. When I first heard of it, I thought it was kind of painful to hear about. But I don't know, the name stuck. And it ushered in a new era of practitioners and ways of doing stuff. But yeah, I don't know. Back to your other question, though, why isn't there a modern marketing stack? Why isn't there a modern HR stack?
There's one called CDP, which is.
Yeah, I was about to say CDPs,
stack.
though, right? That could be the equivalent of the modern
I think it's all about marketing. If I put my marketing hat on,
yeah,
it's just easy to sell and market these things, right? That's just
because what else are you going to call it? Like the modular data stack, which is what it really was, a cloud-based modular data stack.
Well, either that or you say it's Fivetran, DBT, and Snowflake, and this and that. Like you have to give it a name.
Yeah.
I think the challenge that I have with modern data stack and also data mesh is that they come across as technical things, but they're not.
Yeah.
Like data mesh is not a technical thing. Like I know when it came out when I was at AWS, like everybody came to us like, I want to build data mesh. Like what tools do you have to build data mesh? Like it's called data mesh, but it's not a technical thing. It's not a product you buy. It's not a technology stack. So I think we kind of confuse ourselves with some of these terms because they're catchy. They're very markety. And that was kind of like my couple slides.
It works so well that we're talking about it.
Yeah,
exactly.
Yeah. I think there's another reason, which is to go and get the budget for a new project. You can't go and call it the same name. Others say, well, I've just given you the money for that. So you've just done a big data platform, and you're going to spend £2 million there. And they say, well, okay, we're going to do another big data platform, but you've already bought one. Oh no, we're going to rebadge. It's called a modern data stack. So it's an opportunity to hide our failures and blame it on the technology and say, don't worry, it's going to work fine this time. So.
Actually, a short comment on that. So the data world is such so complex. We need to find ways to categorize it to make it kind of get the feeling of control at least.
Yeah.
So I think that is one reason.
Yeah.
And it's basically a venture capital phenomena, the modern data stack.
But also there was this divide between the existing old systems and you had to bring some marketing term to say that the modern way is a new way. And there was a huge divide between moving to the cloud, the initial moving to the cloud, and now this gotten to be the default thing for many companies. You could just delete modern and just say data stack,
yep.
I guess.
And don't call it a postmodern data stack because we're going to go after that. It's just post. Yeah.
There's definitely correlation. I mean, so I remember I remember first seeing Looker. It was in 2014. I visited their office. I thought it was really cool, but I also had developed Rails and Django apps before, and what I realized is they just simply took the ORM, object relational mapper, from those, and then they applied it to data, and I was like, that's cool, clever. It was actually really cool at the time, right? Write once and reuse. And then I remember getting an email. I think it was from Taylor Murphy or whoever it was from. Not Taylor Murphy. Taylor Brown from Fivetran. So at that time, he was still the founder and still sending out cold emails to people saying, try out this product called Fivetran. And he's like, we do this thing called ELT. And I was like, this is the dumbest fucking thing I've ever heard of in my life. But then I realized, okay, actually he's onto something. Later that day, I was like, this is actually really smart for certain things. And so, you know, I didn't have a use case for it because I already had something that worked. But, and so that was, 2015, 2016, right? But then, that data companies were successful. Snowflake took off, and then low interest rates became lower, and pretty soon everybody and their mother had a data company, and this modern data stack thing took off. And I think that's just, so you had to attach whatever name was popular to what you're doing. And I think that's part of how this also exploded, Matt, was that the, Matt Turk's Mad Data Landscape, I'm sure you've all seen that hellscape of a slide, but I mean, he also jokes about it too. I think there was like 1,700 companies on that slide, and that was half of the available companies that they'd actually assessed. But that was a phenomenon. You need the James Webb Telescope to see like logos on it, but the low interest rates is definitely a big piece of that. I mean, that's undeniable. How would you have? Because it turned into like not just verticals, but micro verticals. And how could you have 12 companies competing in a micro vertical where the total addressable market is probably the size of less than a third world country? It's like, doesn't make any sense, right?
Yeah. I definitely remember the first time I came across the modern data stack phrase at, it was Big Data London 2019, and I think it was the partnership between Fivetran, Snowflake, and I believe it was Looker, actually, was the BI tool. In that specific, in-person marketing campaign at Big Data London. Now, one of the things that I remember, talking to a lot of the teams that, describe themselves as ELT stacks, and this is coming back to your point about, hey, interest rates went up, now we're talking about modern data stack dying. Well, okay, so I think there's a couple things, and it has to do with the pattern of ELT, which in its, it's very much implying that you may not know the business use cases up front. You just want to load data to a warehouse and figure out what to do with it later. Now, that might work in a zero interest rate environment where you can go buy all these tools and shiny technologies and hire all these data engineers to run all this infrastructure. And then when you ask someone, well, what's the business value? What are the use cases you've deployed? What's this and that? There might be some reports, but it's hard to measure the actual how that ties back to the business and is creating revenue and ROI and how it's operationalized. Now, when I actually work with data teams that do generate revenue from their operations, it's very rarely ELT. I mean, it's usually very specific business use cases that do require some thinking and transformation and modeling up front, which is, there was so much talk about this today. So, that might be, the death of the modern data stack, is because interest rates are rising. Teams are under pressure to prove value, right? So you can't just buy all these tools and stick them together. You actually have to deliver a product and deliver internal value to your company, which kind of goes against the whole ELT modern data stack paradigm.
But I'd also argue that it won in some ways. I mean, it did prove that in some use cases you could use a modular cloud-based first approach too. And I think that none of us want to go back to the old days of negotiating with certain large vendors with onerous terms and giant legal teams. If you want to do that, you can do that.
Do you think we're going to get back to that stage though, with the companies at the moment becoming so big that they just become the next Oracles or the next IBMs?
Oracle's flying right now. I mean, when I actually go out and talk to the companies that have the biggest budgets, I mean, I see them going back to Oracle. I mean, Oracle's putting out, an autonomous, globally distributed database. I mean, they're going to sell a lot of that, right? They're being very aggressive in the market. Larry Ellison went out at Open World and called out Snowflake specifically with their HeatWave product. I'm not endorsing their product, but he specifically called out Snowflake, saying, "Hey, we got this HeatWave product." He threw out some numbers like we're 3 times faster and 17 times cheaper. I can't validate any of those claims, but
Larry Ellison.
It is Larry. I mean, he did call Salesforce the cockroach motel of the cloud, and he said a lot of very, very provocative things. But Oracle Cloud is also right behind Google Cloud right now in terms of adoption. They have the full cloud stack, so it's going to be interesting. And to Joe's point, like, hey, yeah, it was, there's some predatory practices. There was, they would bring in legal teams and audit you and all this nasty stuff. People wanted to get away from it. But that's like a cyclical thing, right? Because that can go away, and commercial models can become friendly again, as soon as it hits their pocketbooks.
But that was the advantage of the modern data stack, is you could just get all this infrastructure without having to deal with a bunch of dickhead lawyers and fuckfaces and stuff like that, right? So it's like, so it got rid of all that. I don't think Oracle's going to say like, you should go back and deal with our dickwad lawyers here, right? Like that's all going away. That consumption model, I don't know why on earth you'd ever want to go back to that.
Yeah,
unless
but-
you're
Well, hey, Oracle Cloud has no egress costs. I'll just say that.
Yeah. So that's cool. So that's what I think the success of the modern data stack was, that consumption model though, and bringing that to the forefront for analytics.
I don't know. I think we're attributing way too much to the modern data stack. That
Okay.
all
Well, what
that
do you want to
stuff-
talk about, Ray?
All that stuff existed way before the VCs put the marketing label of modern data stack. All
Well,
that
yeah,
stuff
AWS
existed.
did it though with Redshift, right? And before
Yeah,
that even.
all that stuff existed. There's nothing new about modern data stack aside from here's a bunch of companies supported by the
I will
same
push back on
VCs
that though. I will
we
debate
really wanna
you on
push.
this, because how many? Okay, so I
Getting
think that
spicy.
the rise of like SaaS-based tools, though, right? I mean, Upsolver wouldn't, that pricing model wouldn't, a consumption model wouldn't exist without the popularity of the modern data stack.
No, I don't think so.
Yeah,
I think
I
that
think that's the
existed.
advantage of what it brought to the table.
No, I think the modern data stack brought what? The consumption model that existed everywhere in AWS before, Google, Azure. Redshift was doing the same stuff that Snowflake was doing. The only difference, Snowflake was more of a SaaS offering as opposed to like a deployment kind of infrastructure, right? I think the modern data stack, in my opinion, really packaged a bunch of tools together. So like as a customer, it's easier for you to buy a package as opposed to buy a bunch of piece parts, right? And when you buy a package that's already integrated and well tested, it's easier for you to say, hey, I don't have to talk to anybody, right? I just have a stack, I know it's working. But now people are realizing, hey, the stack was cool, but there's all these problems with it. Yeah. Right now they're saying, let's unpack that. And I think the other problem too is that as humans, we love tragedy. So like, let's bring something up, let's bring something down, and then the next thing will come back up again.
But that's a good point. It coincided with the death of Hadoop, right? I mean, it's kind of like
it dead?
We love
you
killing
kill
things. We love killing things because we can bring up the next thing.
exactly.
And we can talk about it. Look how much time we're spending on it.
So, I mean, before, in fact, we
It
probably
goes.
need to ask more questions, really, because
goes.
we've been ranting on the same one for a little while. But the consumption model is interesting. You compared it to AWS and how they started that. But they started out with just, here's some infrastructure. That infrastructure costs this much in your data center. There you go. It's going to be cheaper for you. When Snowflake came along, you can pay per query. But how long is that query going to take, and how
you
much
don't
is
pay
it really
per query.
worth?
You
Sorry?
pay per compute.
Yeah, pay for the compute. But you're paying for the compute from the time slice piece. But you don't know how long a query would last until, would
Right.
run normally. And Redshift created that environment because you had something to compare against. I'm running on Redshift. How much it costs me? I've run the same workload. It's these credits, but it costs me less. Okay, and now I'm bought into the consumption model. But before you had something to compare, is that consumption model a good value? Otherwise, you're just buying magic beans for a price. You don't know what
right.
that magic bean is going to give you.
Yeah. That's also the challenge that BigQuery had.
Yeah.
Right? Because they were doing the same thing. They got this slot idea, and nobody had any idea how to interpret that.
I don't think anyone still does.
I don't think so. I don't think so either.
Right, should we go for another question?
Yes.
All right, okay. Like, is it about modern data stack? Oh, yeah, you go. There you go. There you go, Keith.
We've talked a lot about, say, the modern data stack and move to the modern data platform. The reality that I see, and we haven't really touched on it today, is that actually there's each customer, each bank, or each large enterprise actually has several modern data platforms. And actually the big problem we're seeing now is actually each modern data platform is effectively a data silo with its own data gravity, whether it's like AI platforms like Jay demoed earlier, but also with Databricks and others. And there's not really an interoperable access plane, and there's not an interoperable data plane as well between them. So how do you think we can fix this?
Yeah, so I don't know if you saw my presentation, but I had a slide that says exactly that, right? Where I had 3 sort of like modern silos, right? And I think for my opinion, the data plane and sort of the data access plane is sort of that standard shared storage, right? And maybe it's the answer to everything, maybe it's not the answer to everything, but I think that's the beginning of having that standard, because otherwise you just create the modern silos, and then you're onto the same problems.
No, I really like that, to be honest. And using Iceberg as an example, lots of vendors are now standardizing on Iceberg, but take Databricks, for example. they have uniform, which translates like to and from Iceberg, but it's not exactly the same. And you end up with basically now we're going to have like an Iceberg standard between like AWS and Redshift and Snowflake, for example, and that will actually work very well with that example you mentioned. But then customers then that have Databricks in addition actually ends up with this silo between Databricks and Unity and Delta Lake versus everything else.
Yeah, well, who is it? Paul Rankin and Omar, actually, you were talking about team topologies. I think it's also one of the manifestations that you're seeing is based upon it's just Conway's law, right? So you're going to design systems according to the way your company communicates. There's sort of an inviolable rule. I'm actually very curious how this works in shared data. You called it Lake House or whatever. Justin Borgman jokingly called it the Ice House the other day, which is
Yeah, I know. I saw that.
which
we
is
don't need
cool.
more names.
Yeah, well, let's actually come up with more names while we're here. But I mean, what I predict is, this can go two ways, really. But I actually think, let me go back. I was really impressed by the fact you guys were talking about fracture planes and all this other stuff, because I think that's something that goes unnoticed by a lot of data practitioners, that we just feel like, oh, we'll just keep buying solutions, and that'll solve our problems. But you don't address the inherent organizational challenges right now. I mean, that's just something Matt and I encounter with our consulting, is that we're hired to do architecture, and avoiding the human dynamic, the organizational dynamic, if you're looking at architecture, is, I think, professional malpractice. In fact, in one case, we're advising a company to they have to reorg things if they want it to work. No matter how much tooling they throw at the problem, it simply won't work. It cannot work.
I think there's two more comments to that. I think one of them is, first of all, we're still in the early days, right? So we're going to see this fragmentation for a little bit longer, but these things will eventually work out. I think the other side to that, kind of the organizational structure, what I've seen, and it's harder to do. I'm not saying it's easy to do, but you do sort of have a company come back and say, like, look, we're going to standardize on this. Let's call it Iceberg, for example, right? I've seen this in Parquet a couple years ago, where it was JSON and ORC and all this stuff, and the companies basically said, look, everything we're generating is going to be Parquet, period, right? And then Databricks does it, and everybody else does it. Now we're in kind of the next phase, right? So today we kind of competing Iceberg, Delta, Hoodie. Eventually it's going to normalize. We're going to get to a common ground, and then companies will eventually say, like, look, you can do whatever you want, pick Snowflake, Databricks, whoever, but you have to store in Iceberg, and that's just the way it's going to be.
So yeah, going back to your question, and why no one's talked about, this interoperability layer. It's actually very difficult. Yeah, and let me just give you the experience of a large pharmaceutical company that I used to work for. So for the last 2 years, well, at the start of our data mesh implementation, we said, okay, we're going to focus on our 3 data stores, data platforms, if you like. Yeah, Redshift, Snowflake, and SAP. Yep, and we're going to try and make everything, all these 3 data platforms, interoperable using virtualization technology. This was a big thing 2 years ago. This would solve all our problems. We brought in Denodo, we brought in Starburst, we brought in some other organizations who could tell us they would fix this for us. Yeah, we spent 10 million in 2 years trying to put in a virtualization layer on top of these 3 data platforms. Yep, and it failed miserably. So what we did, we kicked out Redshift, said we don't need Redshift. Okay. It's not a market leader. I'm just winding you up. but we really did. And then we will end up with SAP and Snowflake, and we learned pretty quickly that the less, technologies you've got in the underlying data store, for one, the easier your journey will be. Because, you have to build integrations for everything, on all these different technologies. For shopping, for publishing, for consumption, for fulfillment, everything. And really, the amount of money you can throw at this is limitless, as what our experience, as Roche.
Yeah, I work with quite a few Fortune 100 companies that are replicating data across clouds, and it does come up. Why do you have AWS and Azure? Why do you have AWS and GCP? Why do you have BigQuery and Snowflake? And then this is the same infrastructure teams working with these products. And ultimately it comes down to who's willing to pay for it and what are they doing with it. because the technical problems can be solved, right? You can either do virtualization or open storage. There's all types of innovations in the market. You can do replication with streaming. I mean, all those are in the realm of possibility. Yeah, it sounds like some technical debt and overhead that maybe data engineering teams don't want to deal with. But ultimately, someone's making that investment within the company, and either they're aware of the overhead or at some level they think it's justified. A common topology I see is AWS for engineering and Azure with Fabric and Snowflake and Power BI for analytics, right? And it ultimately comes down to the chief data officer had the relationship with Microsoft, and the CTO has the relationship with AWS. So it comes back to who's the one who's actually owns the budget and the project success. So yeah, I think the technology can fill the gap there, but I do see this being a pretty common problem going forward. And I've also been in these discussions with more financially driven operator types who said, yeah, I got a deal from this other cloud provider to essentially cut our costs, and I sent out a mandate that 40% of our cloud workloads will move to this other cloud, even though we're on cloud A today. And my engineering had a mutiny over it, and there's all these organizational issues that may pop up, but I don't see this problem going away. I would obviously recommend to any team to use one cloud and one stack for as long as they can, the modern data stack. No, I'm joking.
The new one or the current one or the old one? Which one?
The one we killed and resurrected with the version we like here, the Swiss data stack.
I love it.
I just wanted to add something here. It's important to say that by spawning new, it's actually irrelevant whether you're in GCP or AWS if it provides you the same functionality. But what teams always fail to do is to say, okay, if we spawn this new functionality here, which one are we shutting down? Yep. Because then otherwise, some point the CFO comes or their people come and say, okay, what are you guys doing here, right? And if you miss, doing that, then you just building another problem.
I think you mentioned the word gravity. I like that term of data-driven gravity. And, you bring, as we've seen with Cortex and everything else, we're bringing all the compute, all the analysis to where the data is. We talk about that virtualization. Now, I don't know the actual project you're talking about, but sometimes it's like, okay, let's go. We want to do this, but we haven't actually got the use cases. Let's actually look at with that data gravity aspect and go, well, all that data is actually located here. It satisfies that use case. It's just missing one bit. So maybe I only need to move one bit to that same location. I think we're missing actually having traceability back down to a use case, actually finding out what data is actually needed, and then the best location to put it with the cheapest effort in migrating it. Should we have another question? Yeah. You got another one or no? Anyone else? Next question. Yep. Is that Yuri? Yeah, I'll bring you the mic. Here you go.
I don't want to say again modern data stack. I had a conversation a few weeks ago with like Fortune 50 business leader. He told me you got that modern data stack, but everything with data is stuck. And I was wondering why it's so hard to move the needle and create business value with data. And I think today everybody we're talking about concepts and how we can solve everything. Okay.
I got her better help so she'll be fine.
So maybe like a small question. It seems like over the past years, infrastructure and data infrastructure, we've made like a great progress. And I was wondering if you think verticalizing will really gonna solve part of the pain that we're seeing today, or we're just going to continue improving our technology and making life more easier for business leaders. Because I'm talking about business value eventually. So
you mean like an industry-specific data stack?
Yeah.
Like a financial data stack.
Like a CDP for.
Well, I mean, you are seeing evidence of that with the large data warehouse providers and cloud providers. Like Snowflake has a healthcare cloud, and I don't know to what extent they're adding features and capabilities around that, but it seems like they are, and So, that can add some incremental value. I'm curious to see what the panel is seeing on that.
This is why Oracle makes so much money and continues to do so, because they've done just that, right? For finance, for aviation, for many other industries. And you don't see this, it doesn't get advertised. This isn't really the cool cloud business. But they've locked these industries in a way that they're in there for the long run. And so whether that integration is great, yeah, for Oracle.
I think there's one other view on this as well, I've got, is that go back to that data as gravity, and maybe actually not only that data as gravity, the actual applications have got gravity are coming to where more and more that data is. And if we think about, and I had Malcolm Hawker on the show the other day, and he was wasn't saying favourite thing about data mesh, but about data products he was. But and I think the point he was making is, will this operational world and analytical world come closer together? Before they were so far apart. It was your data warehouse, it's a downstream process. It was never really part of your, it wasn't DR, didn't have failover. And then after that, we started building all these dependencies on it. I mean, oh God, we've got to actually go and support all this now. And DevOps, data ops coming closer together. That when the deployments of DevOps, you need to do data ops as well. So they are coming closer. And technology allows us to have the Unistore or an OLTP transactions as well as OLAP transactions in the same location on the same data, maybe on Iceberg data. And we've already got pre-built templates for, here's an e-commerce company, standard. There you go. You need Salesforce, you need your modern operational stack. You have the standard components that an e-commerce company would have, and you'd already have the mappings for the data model already defined, and then you extend it afterwards. I don't know how far away that is, but that's where we should be heading to. I'd like to think that's our North Star.
Maybe just two things. By sitting. Yeah. So I think the industry of data is very young and maybe a little bit immature and easily distracted by every new shining thing coming out. Some of the shining things we saw today. No disrespect to all of you. You're right. But secondly, this young, spoiled brat kid has too much money at stake. The whole ecosystem is trillions of dollars at stake right now. And because we have money, everybody is enjoying this. Today is this, tomorrow is that. I will not be surprised at all if we get vertical domain specific data stacks or something like that. So that's my view, and some of the scars that Saul was sharing. That's exactly what happens in the enterprises. Somebody is playing golf with somebody, and you implement that tomorrow. The other executive is playing golf on the other golf course with the other CEO of the company, and that function, or skiing, or skiing. So one is skiing in Europe, other one is skiing in US. Guess what's happening? That's exactly what's happening in reality. And
Can I'm just gonna.
Just second point.
Yep. Please. Yeah, okay.
I'm my personal wish to your example of the operational and analytical
coming
together. What's the technology you guys have? No.
Unistore.
Which one? Cortex?
No, the table, the dynamic.
Hybrid tables.
Sorry?
The dynamic tables and hybrid table.
Tables type of things will prevail, which means the E and the L of the ELT will be gone. So it may be push and transform in future. Oh, another buzzword.
So it's called PAT. Push and transform.
Push and transform.
That's it.
Here you go. You heard it here first.
Yeah, just going back to Uriel's question, I think it's really interesting because, I don't know, I feel like we're maybe making this a bit complicated. Like if you zoom out, there are loads of SaaS products that have basically done like a sort of data team specific use case from day one, right? So everyone knows Amplitude, right? That's basically what a data team would do if the product team came to them and say, hey, I need to work out what's going on with my product, right? It's like you go on to marketing. It's like there are marketing consultancies that just have multi-tenanted data stacks that are doing the marketing analytics that data teams do. And then obviously at the very end of the, enterprise spectrum, you have Oracle that are just producing data products and, hanging out with the CEOs of Boeing or whatever. But I don't think that's really like super representative of everything else. You just kind of have vertical SaaS that does what a data team does, selling into business leaders.
Yeah, that's a really good point, Hugo. And the other thing you're seeing a lot of now is these vertical applications have their native Snowflake connector. I mean, Stripe has its Snowflake connector. Salesforce has both BigQuery and Snowflake connectors, and they're treating the data stack as kind of the back end for their own application. You're seeing more of that too. Like for instance, internally at Stream, I mean, we were a big mix panel shop for a long time. Now we've essentially built a data stack, and we're still syncing data back into Mixpanel and pre-processing the data and obfuscating it in the data warehousing layer, because doing that in Mixpanel was hard before. But Mixpanel even has a native connector to our warehouse now. So it's like even coming back to verticalization, definitely is going to be a powerful concept, and the vertical applications are already recognizing the valuable role of the data providers. So I think we're going to see more of that even in an enterprise context. I mean,
I'll just add to that. I think the answer is yes. It's going to happen. It's happened in the past. Like Salesforce, if you look, they got Marketing Cloud, they got Sales Cloud. There's lots of it. Like CDP is, Marketing Cloud kind of bundled. I think to John's point, what's going to be different is that you're not going to need an entire stack just for that industry. You're going to have a generalized stack, right? Whether it's Iceberg or Snowflake or whatever, and then the applications on top will be the specialized ones, right? So it's much easier for you to develop that specialization for that particular industry without changing the underlying stack, creating more silos in the industry. Because right now we basically create another silo for marketing, another silo for sales, right? We don't want to do that. We want to have a standard storage layer, right? Shared storage, and on top of that, you get the applications. And I think Snowflake, with the container service and everything else, is like the perfect spot for that.
Cool. Well, more questions? Yeah. Good. We get past it.
Right, so you've all got your relevant stacks, your backgrounds, and your experiences. For, I don't know, someone has just come out of university, wants to be an aspiring data engineer. What would you say the core skills they should invest their time in are, like from each of you? Paul, you had your slide up there, delivering that value, the analytics that can be done. Actually, it's removing something up here that was like from a data team. So that engineer might feel a threat from that. But equally, they could invest their time in learning ThoughtSpot or features in and around that. So what would the skills you'd say?
Well, I think I have an opinion on this.
Of course you do.
No, well, I can. I'll only give you part A of part one of the answer. But no, it's related to the course I'm working on right now, actually, for deep learning AI. So it's a data engineering course. And by course I mean 16 weeks of fun. And when I thought about what does a data engineer need to know, and how would I train a data engineer coming out of uni, or how would I train one from scratch? I thought about a lot of the ways that we teach people now, right? So there's a lot of tutorials on learn data engineering with Spark, and it's a lot of like spin up Spark in a tutorial, and I think that's ridiculous. For one, if you're coming out of uni, I hire you as a data engineer, there's no way in hell I'm going to let you spin up anything from scratch. So let's erase that idea from your mind immediately, right? What I am going to have you do is maybe go get familiar with the business, get familiar with stakeholders, work on some menial projects, maybe connect to a database. And so the approach I'm taking is exactly opposite, where you might need to interview stakeholders. And one scenario, you might be interviewing a chief data officer and understanding what the chief data officer is looking for, and doing requirements gathering, understanding what you should be building before you go build it, and what you're supposed to be doing before you go do it. This is one of the things I think is very underrated. I mean, Matt and I teach SQL at university, for example. People like our class. It has very high marks because we take a very industry-specific approach. Most of the academics that teach, they're still teaching Hadoop, for God's sake. It's ridiculous how antiquated this shit is. Yeah, I won't even get into that. But that's the approach I would take, right? And so one of the other, I was just actually going through some labs for my course. One of the labs is, hey, it's your first day on the job, or your first week. You need to go connect to a database to start getting some information. Holy shit, you can't connect to the database. What happened, right? You got to figure out permissions, networking, all the fun stuff that you should learn. So these are all this is how I would teach it. It's very much, you're going to be fixing things rather than like creating and architecting from scratch. That's not the reality of somebody coming out of university. You know, you're going to be shoveling manure from point A to B and then back to A and doing that job over again all day. That's your job. But that's, I think, how you learn. So
yes, I don't think you really answered it though. Okay, so what you described to me is, okay, let them go away, understand, or we'll teach them skills on SDLC, elaboration of requirements, making sure we're going to deliver the right thing for what the customer wants, for what they're going to pay for. So, so they're providing some return on what we're investing in them.
Yeah,
or they're investing in themselves.
I mean, I'll tell you what happens right now in the university curriculum when somebody comes out as a data science degree, because that's a bit more established. Every data science graduate I've seen comes out shocked that data is not perfect, right? The systems aren't set up. And for most part, when you're hired at some jobs, like Matt and I sometimes, there's a reason we call ourselves recovering data scientists, because we get into jobs and holy shit, there's no data upon which to do the science. And so what do you think happens? Matt and I have great work ethics, so we set out designing systems and building them, but like wasn't our job, shouldn't it be? But but the thing is, it's a very sanitary way of looking at the world, these courses, and I think it's completely backwards actually. So that's how I teach.
Yeah, this may be controversial. I don't think that word is going to exist in 5 years.
Which word?
Data engineering.
Yeah, it might not.
So I think coming out of school right now, you're going to learn the basics and the fundamentals and how to build an ETL script and build data pipelines. You're going to learn code and your ingest and data architecture and modeling and semantic layers and all the crap that they teach you in school. But if you take a look at the function of analytics and how we used to have to build a very sophisticated data architecture in order to get the data in a good enough shape so that we could consume it, manipulate it, extract it, and then come up with some sort of intelligence. With what's coming out today with some of the startups, like you're bypassing that entire process. You don't have to actually, you're collecting the data, but you can skip the process of connecting the data, which is where most companies trip and fall. And it's where most engineers are fundamentally needed. And so I think with the current capabilities, if they catch up to where, if they've caught up in the analytics space, they're going to catch up in the data engineering space. So I would say you have a job right now. I don't think data engineering in 5 years is going to be a term. I think it's going to look very, very differently.
So
like ETL developer.
So I have to agree with that. And I wrote a post about this a little while ago, where the kind of the role of data engineering is really splitting up into platform engineering and analysts. So I think ultimately you can choose to be an engineer and go build platforms and connect the dots and run the wires and do all that kind of stuff. Or you can be on the business side, writing the SQL, doing the business kind of thing, and you don't really need to worry about how to set up a database, how to connect to it, because the platform team is going to get it for you, right? Because ultimately, at the end of the day, like this is all grunt work. Yes, we all have to go through it. I don't think the future people will.
Well, I have a
comment there that it should be already that way. There's the people who are actually trying to answer the business questions from the data and focused on the data, not fiddling around with the platform. So I think that's ultimately where things are going to go in the future. This makes more sense.
I just want to share a different view on this one. We have, for example, a COBOL Academy where we teach young people COBOL, right? Because it's just needed. And doing data engineering with COBOL, just creating reports out of mainframe, like that's still a thing. And so the Lindy effect, right?
How old are the people you're teaching, though?
They're just coming out of. We try to get them out of school. Like they're usually not university graduates.
So you have 21-year-olds wanting to learn Cobalt?
Yes. Yeah, they learn COBOL.
Are they in a
it's all consensual. Okay?
They're not in the gulag.
Context matters. What city, in what town, in what village, and all 6 of them took your Cobalt course?
Well, to be honest, like if you look at most of continental Europe, there's a lot of mainframing and COBOL and PL1 still in the banking industry, insurance. So but just to give you an example, obviously it's a niche thing, right? I'm
But the rates are high. That's why they're doing it.
But the point is, these things tend to stay a lot longer, right? Than you think. Yes, what I agree is probably it's not going to be called data engineer, because what these people in Kobo are doing, they never call themselves data engineer, even though they're just pulling data and creating reports or outputting some batch. But some of these old technologies that remain will take longer to get out of the landscape.
Well, Matt and I call this out in our book. I mean, we even, I think we said that data engineering as a title may go away, but I think the function of the data engineer, I mean, I think at least as long as I've been around, I've heard that systems were going to get simpler all along, and they sure do, but that always introduces new complexities. And then I think we're also ignoring the fact that there's the dark matter of the data world, which is Excel, where everyone else works. And here we are talking about data stacks to which the Excel isn't even attached. And so I think we actually have a long ways to go. I'm sorry, I do disagree with all of you.
The stack is going to have Excel in it now.
Well, I mean, you can make a pretty strong argument that the most prolific data stack in the world is Excel, and now you can do Python in it. It's the best IDE in the world.
But he did ask a question. What should the data engineer know coming out of school? One, there will be hundreds of options on a yearly basis to choose as part of your tech stack. So they have to have a mindset of fluidity, and that change is the only constant.
That's key.
That they have to be just foundationally set on. Mm-hmm. Two, what they know is data engineering today and what they've been taught in school may or may not exist in 2 years or in 4 years, and they're going to have to adapt and evolve. Three, the company that they choose to work for will actually determine, I think, their career path more than anything else. If you go in some of these legacy-based industries where they're still very much mainframe operator, or they just moved from on-prem to cloud like 6 weeks ago, the classic, fundamental, old-school, traditional way of doing data engineer will be around, yes, for at least a decade, no doubt about it. But if they go into a startup or into a tech-based company where tech wasn't an afterthought, but tech was at the forefront, the demands will fundamentally be very, very different. And I think it's going to come down to the individual's personality as to where they bifurcate in the world of data engineering.
Tell them to retrain on something else.
I think,
I think Jensen Huang, from CEO of NVIDIA, already said, and this is a very controversial statement, that kids shouldn't be learning to program anymore. And now with Copilot and things along those lines, the demand for people who can come up with technical solutions, well-defined problems, is going to decrease. People who know how to define the problems the demand for people who know how to define the problems is going to increase, right? So having that emotional, organizational IQ, right, and being able to actually go and solve the business problem is going to be the key skill, rather than just like knowing how to develop and architect the solution, because you're just going to see so many more people who are able to pick up the engineering skills as a commodity. And I say this as someone who with a computer science degree, like the amount of productivity that new engineers get with these tools is actually pretty glaring in terms of what they're seeing there.
I think you talk about problem. It's actually problem solving. You know what teach them is and soft skills. When that was pulled up at Day-to-Day Texas as well. It's something that.
It's the art of forensics.
Exactly. Yeah.
Define soft skills.
Yes. Soft.
Yep. But this is the skill of the business analyst. Remember where it was cool to have this title, and then it died. Like no one we don't have business analysts. We're agile.
Yep.
We work directly. It's all good. We skipped that, yeah. And now after the kind of the whole agile thing cooled off, business analyst is back in again, right? Yep. And to understand the requirements is no minor feat, right? So.
But what happened to data science since then too, right? Because I remember when data science.
They're recovering now.
Oh, they're recovering, but yeah, I mean, I think you'll all recall back in the early 2010s when data science was the sexiest job, and data analyst was a 4-letter word. Like if you had analyst in your title, you should change it to science.
Like I think one of the things that's happening too that I see in the industry is specialization.
Yeah.
There's always the specialization, then generalization, the specialization. It kind of keeps going in and out. And we're seeing now in the industry, there's just so many touch points within the business that you need to start to specialize more and more. And
so we got 5 more minutes left. So I think Paul, you got a question. I think Chris, you had one as well. Paul, you go first? Go on, throw your voice. Because then it's cocktails. So. Mic's off. No.
I mean, the premise for that was if you take a look at just the way things are going with multimodal functionality, on my teams, I can take a no-code person and make them a high-code person. I would never push any of the code to production without my high-code person reviewing their code. So even if I can automate that process, there's a risk on my end. But now I've got a data analyst that costs me $90,000 versus a data scientist that costs me $250,000. I can hire more data analysts who are no-code and get them to be high-code individuals because things can just fundamentally translate and become more automated based on just prompts or instructions. That's just the way the space is going. And so the comment was made is, I don't think you're going to need to write the ETL scripts. I think at some point in time, the auto integrators are just going to understand what's going to be needed. I'm not saying we're there yet, but you've already started seeing pockets of it. And I've seen it in the analytics space tremendously. Like if I take a look at my headcount, what my OpEx budget is, I don't need as many data scientists as I used to because now I can get my low code and no code individuals to operate as my high code individuals, which isn't a good thing, but that's the reality of it. So I can now produce more because of where we are in 2024, 23, and 22. I think in the space of data engineering, the same trend is going to occur.
Is it kind of a question, though, of doing dumb things faster? Because I feel like we're still going to be bickering about the same questions. Like, are we getting value from our data and all this other hokey bullshit, right? So I feel like it only is an accelerant, but it doesn't actually improve things at the end of the day.
Well, my output has been a lot greater as a result. So
but have you moved the needle as a result of that?
1,000%, because I can do more work with minimal OpEx now. Now, you don't skip the human in the loop, and you don't automatically put the work product out in the market space. You have to still go through the validation process. But what used to take a data scientist 3 weeks, 4 weeks, 5 weeks to model, and I've only got 40 of them when I need 80 of them, I can now get my low-code and no-code talent to function in the same way, and now my data scientists are just reviewing the work and validating it. So I've now taken work that's been months down to weeks, sometimes days. So my output is greater, but I still have a validation process, so I don't skip that for sure. But yes, I can do more with the same amount of individuals with less headcount, or at least with a lower OpEx budget.
I mean, I've seen a lot of these. I stopped taking calls from. So if you have an LLM startup that does ETL, don't call anymore. I've seen a lot of these, and I think they're terrible. They could get better, but what I've seen in a lot of cases is now you can do prompts to make your data pipelines. But for now, given how I guess probabilistic these LLMs are, would I really trust that for what should be an idempotent pipeline? I don't think so.
Right.
I mean, the question, can I get you 50% way there?
I don't want 50. I'd rather do it right the first time.
So assume,
well, am I going to do? Am I going to do prompt reviews now on my team?
But Joe, if you have a data engineer, that just came out of school, they're not going to get it right 100%. So
Exactly.
the premise and the foundation of what you're saying is that they're going to get it right. But I have more errors in human work than anything else. And so if you've got a junior data engineer that doesn't necessarily have context or business domain expertise, they'll have to go through the grooming process and they're going to make several mistakes. But that's a 2-year investment in that person before you can actually trust them to do the work on their own. So I still have to assume a 50% inaccuracy rate with any new hires. Like you're comparing your talent as a data engineer with a lot of the workforce that isn't to the degree that you're at. So there's a lot of inaccuracies we're still dealing with the general workforce.
Yeah. Okay.
We'll take this one to the cocktail room. Okay. Chris?
Is it working? Yeah.
Yep.
So I think there's a lot of really interesting stuff being said today, and I think the thing that I'm going to pick out here is the human element. So it's human and organisational, and the thing is, organisations don't stay static. So global organisations acquire other organisations. They have different working patterns. There's different things going on. So because they're not static, you can't have a static stack. Say the word again, but you can't have that. So you need a capability to maneuver around the landscape that's in front of you. And I think that's a key thing there and that's why you get even within global organizations, disparity of systems, that causes disruption. The use of the systems, even if you have a core system, the actual semantics of the data that's put in it can be configured wildly differently from organization to organization. So when you're trying to dissect what's going on, the hardest problem is humans, because you've got to interpret what they're doing. So the biggest problem that we've got, I agree with Sol, is the interpretation and getting to the people who know and understand what's going on to be able to actually deliver. So we've got a very difficult job there. And that's why we have interoperability between platforms now, because you can't just go, we'll have one platform and that will be just it. Because you acquire the next company and they've gone, oh, we had one platform and that was just it.
And that's the thing, like we are constant. It's just a moving target with anything. Even with my favorite quote in the world, and I would always tell my teams this, is, if you asked the people what they wanted, they would have said a faster horse. And that's the problem. Half the time we've gone to the business and saying, what do you want? Yep. They communicate it, we interpret it. They're like, no, that's not what I wanted. Or maybe it was what I wanted 3 months ago. It's not what I want right now. And so it's a constant moving target. So yeah, I would agree for sure.
Last question, if we can. We're going to take
it's just a comment and to sum it up. So I have quite a good view of the larger banks in Europe, for example, and none of them have a technological problem. Yeah, what you've been discussing on the stage is very important, these topics, but it's not, the value just doesn't come to the business or to the customer, even worse. Yeah. So I think the key issue is what Sol raised is really how can you really, or what you also, Chris, in your talk raised is how can you really get the value where you have it? And then once you have this value, so I've seen like last week from larger German companies where they say, okay, they've established a data company and a data setup, and they had planned values of 100 million, and now the business is delivering 200 million because they found out how they can do it, how they can use it, and they found out, so they will over-deliver. It's a program which is 1 billion million, yeah, in investment, but they will over-deliver. Yeah, they already know it now, and this is the environment you need in a company. You need this connection between the business and the data. And what you've been discussing is, it's good, but it's not the real problem. Yeah, the problem is, and the solution, for example, in 2006, I implemented something like MicroStrategy. Yeah, and there was the same. It was the same issue. Yeah, if it works, yeah, you get the business value, then it works. Yeah.
Yeah. Okay. All right. So we're going to go do photos at the stairs just as we go up, and then we'll go across for cocktails, if that's all right.
Oh, yeah.
No.
Put the short guy in front.